Hello, welcome to this online lecture. This lecture will be about probably one of the most important concepts to chemistry, really central to chemistry, that you're going to learn this year, and that is the mole. The mole is just really important to chemistry because without understanding that, you're not understanding one of the most often used measurement tools that chemists have available to them. So what we're going to do in this lecture is we're going to talk about what a mole is, other than that little animal that digs in the ground. And I'm going to show you how you can do calculations using the mole and take an amount given in one measurement unit like mass and convert it into another like moles or number of particles. So let's get started with what the mole is. The mole is a number. So when someone in chemistry is talking about a mole, it's just a number. It's a ridiculously huge number. So I'll write it out for you here. It's 6,022, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So basically, this is what a mole is, and it's a counting number. It's like I'm buzzing. It's like a dozen, right? The mole is a number, just like dozen is a number. It's just that you're really a lot more familiar with the number that a dozen is. But the mole is the same thing. It's just a number. It's just a tremendously huge number. So let's see. That would be thousand, million, billion, trillion, quadrillion, quintillion, sextillion. So a mole is 602 sextillion, 200 quintillion. That's what a mole is, and it's just a ridiculously huge number. But again, it's just a number that we can use to count things. You know, when once we have this many things, then we can say, okay, that's one mole, and then we keep counting, and then when we get to this many things again, we can say, okay, that's two moles, just like the way we use a dozen. You know, when we get to 12 things, we say that's one dozen. When we get to 12 things again, we say there's 2 dozen. That's all that it is. So why such a huge number? Well, because it's used to count things that are incredibly, incredibly small, like atoms and molecules. Since atoms and molecules are so ridiculously small, there are a tremendously large number of them in even, the smallest pieces of observable matter. So basically that's what the mole is. The mole is this number right here. It's just the name of this number. So one mole is this many things. Now, we're not going to write this huge number out over and over and over again in this class. That would be ridiculous. We have to use scientific notation. And hopefully you've learned about scientific notation in one of your math classes before, but there's a couple different ways that you can write a number in scientific notation. But in scientific notation, the mole is 6.022 times 10 to the 23rd. And basically what this means is you take 10 and you multiply it by itself 23 times, and you multiply that by 6.022. And basically what that does is it'll move this decimal point 23 places to the right, which is the number that I have written out for you over here. Now this is probably the more common format for writing by hand scientific notation, but in a calculator you're almost always going to see there's some calculators that do the times 10, but you'll often see a capital E and then 23 like this. So both of these mean the same thing. It means take 10 and multiply it by itself 23 times, and then multiply it by this number, or the way I like to remember it is just take the decimal point and move it 23 places this way. So that's what the mole is. It's just a ginormous, huge number that we use for counting lots and lots and lots and lots and lots of things. And there's a whole bunch of interesting and funny videos about just how big this number is. And I have links to some of those in the course that you can check out later if you'd like to. So if that's what the mole is, if it's just a big, huge number that we use to count atoms and molecules and particles and things like that, what do we do with it in chemistry? And the answer to that is basically we have to use the mole because in chemistry, it's particles and atoms. Those are the things that are reacting and combining and breaking apart. And so anytime we need any kind of a ratio, we need to have a ratio of particles. So we use the mole to count how many particles there are. And then by using the mole, we can have numbers like 1.2 moles or 5 moles instead of having, weird, crazy, huge numbers like this. So what I'm going to show you now is that you can actually take amounts. We can't measure, there's no instrument in a chemistry lab anywhere where you pour in some matter and it counts the number of particles and then that pops up on a display. We can't directly measure the number of particles in something. But what it's very easy for us to measure is mass. We can measure the mass of something and, we'll get grams. That's the System International unit for mass, the metric system unit for mass. And that's really easy to measure in a lab. You just have to have a balance to do that, or a scale, a digital scale or something. And what's really good news for us is that you can take a measurement that's in mass and you can convert it to a measurement in moles. So you can go from measuring the amount of matter in mass to measuring the amount of matter in moles, which is kind of a way of saying how many particles there are. It's just that you're counting the particles in this giant, huge number. So because you're essentially at that point counting particles anyway, you can also take that amount and you can measure it in straight up number of particles. And what's interesting is not only can you go this way with the measurements that you have, but it works both ways. You can actually convert both ways. So what I'm going to show you now is how to do conversions like this. I'm not sure I'm going to get through all of my examples that I want to get through in one video, so if we don't make it to the end with this video, we'll have to do a part 2. But let's get started so we don't waste any time here. The first thing I'm going to talk to you about is how you go from mass to moles or moles to mass. By the way, the abbreviation for moles is MOL. I know that's not much of an abbreviation, but that's what it is. So, the way you go from mass to moles or moles to mass is by knowing the molar mass of whatever it is that you're trying to convert. The molar mass. And what the molar mass is, it's the number of grams in 1 mole of something. The number of grams in 1 mole of something. That's what the molar mass is, and that's the unit that it's measured in. It's measured in grams per mole. That's called the molar mass. And where do you find the molar mass? This is really important. You find, because you're going to be finding the molar mass a lot in this class as time goes on, but you find the molar mass on the periodic table. So let me bring up the periodic table here really quickly, and I'll show you what I'm talking about. This mass on the periodic table, you see on this table it's labeled as weight, and you'll sometimes hear it called that too. But this number on the periodic table that's called weight, oops, sorry about that, right here, it's going to be a decimal number for all the elements. This is where it's at on this periodic table. It might be somewhere else in a different periodic table. That is the molar mass in grams per mole of that element. So if you're looking for a molar mass, you have to look on the periodic table. And the molar mass is really important to us because the molar mass allows us to convert back and forth between the mass of something and the number of moles of something. So let me show you an example of that. Let's say that I had, well, I'm 37. So let's say I had, oops, sorry about that. A little technical glitch there. Let's say I had 37 grams of, let's say iron. 37 grams of iron. Now 37 grams is a mass, right? And so let's say that for whatever reason we needed to know how many moles of iron that was. And moles, right, is here. So we want to go from mass, grams, to moles over here. And to do that we have to know the molar mass. So I'm going to look down here. hold on one second. What did I say we had to know? We had to know the molar mass, right? Okay, awesome. So again, I'm going to turn the periodic table on. Scroll down here and turn it on. Bam. Okay, so what did I say? I said iron, didn't I? So the molar mass of iron is right here. Now for this class, whenever we're using a molar mass, 2 decimal places is fine. Completely fine for what we're doing here. So the molar mass of iron, according to this periodic table, is 55.845. Using rounding rules, because there's not another number right here, we're going to say 55.84 for the molar mass of iron. So I'm going to scroll back up. I got to turn the periodic table off. I'm going to scroll back up. All right, and so we know that I did it again. Sorry about that. I keep doing it. So we know that 55.85 grams per mole is the molar mass of iron. And what this is saying is that if you have 55.85 grams of iron, then you have 1 mole of iron. Which means that if you have 55.85 grams of iron, you have this many atoms of iron. That's basically what the molar mass is telling you. So what we're going to do is we're going to use something that you learned early on in the course. We're going to use dimensional analysis now to set this up to make sure we do it right. So we're going to draw our little set of fractions here. And we're going to put what we know, which is 37 grams of iron. And you'll notice I put the unit and the substance in there. And then the second fraction is going to be our conversion factor. And our conversion factor for this one is molar mass. Conversion factor. Conversion factor is what gets you from one unit to the other. So here's how this works. We need to set this up so that the units cancel out. If I have grams on the top, I have to put grams down here. And if my conversion factor is molar mass is grams per mole. So the other unit has to be moles, and it's going to go up here. Grams per mole. Just like grams per mole. And if you look at the molar mass, the number goes with the grams. 55.85 is grams. So 55.85 grams per 1 mole. Grams per mole. So the mole gets a 1 with it there. Perfect. Now, if you remember how dimensional analysis works, if there's something that's the same on the top and the bottom of a fraction, it cancels out. So let's look and see for some cancelage here. Looks like I've got grams up here and grams down here. So that's going to cancel out. And the unit that we're left with is moles, which is exactly what we were trying to find. Nothing else cancels out. We have to do some division. So let me bring up my calculator here. All right, here's my calculator. And what I'm going to calculate is 37 divided by 55.85. 55.85. All right? And so I get 0. Now, this number has 4 significant figures. This number has 2, so I'm going to use 2. So for my answer, I'm going to put 0. I got to bring that up again. I do that every time. 0.66. So 0.66. Now this is important. Okay, 0.66 what? 0.66 moles, because it's the only unit that's left that hasn't canceled out. And then what substance? 0.66 moles of iron. So we have converted from an amount in grams to an amount in moles. That's how you do that. So this will be continued in part 2. Thanks for watching, and as always, if you have any questions, please ask in class.